Hi class, Professor Dave here, showing you how to do a contingency table on the Ti83-84. So example 1, promotion and gender. Suppose that the Personnel Department of Insurance Company has compiled data regarding promotion classified by gender. Is promotion and gender dependent on one another? So here's our data, and the null hypothesis for this is that it is independent, or there is no difference amongst the groups. The alternative is the opposite of that. It is dependent, or there is a difference amongst groups. Okay, so let's see how to do that on the calculator. We'll bring the calculator in, turn it on, we'll clear it, and we'll go to, we have to first put this matrix into the calculator. So we go to second matrix, which is right here, or actually just matrix. Okay, so we'll put in matrix A, and we want to edit that, so we'll go here, say enter. Okay, so we need the size of the matrix. The convention is that we go by rows and columns. Columns hold things up, and rows go this way. So it's a 2 by 2 matrix. These are just the totals, so this is what we have here. We have 49 males promoted and 186 males not promoted, for a total of 235 males. And we have 2 females promoted, 33 not, for a total of 35 females. And total promotions is this, total promotion, not promotions is that, total people is 270. So the size of this would be a 2 by 2. So we have to put a 2 by 2 in there. So we say 2 here, and then we go over to here, and 2 here, and then we have our 2 by 2 matrix. So we'll just enter these. 49, enter, 186, enter, 2, enter, and 33, enter. So we have our matrix here. All right, next we go into stats and tests. So stats and over to tests, and we'll go up to a chi-squared test. That's all we do. All right, and it already puts the matrix, the matrix in here. So we have matrix A. You can change that, but we have the matrix A. It will put the expected matrix in here, which we don't have to worry about too much. And then we just go down to calculate. So we hit enter, and we get our values. Our chi-squared value is 4.56, so 4.56, and our p-value is 0.032, 0.032. So we use our kind of relative standing, our p-value, right? The probability of obtaining this sample result right here, under the assumption that it is independent of groups, is pretty darn unlikely. Less than our willingness to make a typo and error. It's not stated, so alpha is 0.05. So we will reject HO, and we'll go with that it is dependent, or, that promotion is dependent upon gender. So since p-value is less than alpha, reject HO, there is sufficient statistical evidence to infer that promotion is dependent on gender. There we go. All right, let's do a second example. Show you the other way. Okay. So example number 2 is policy and type of worker. All right, the trustees of a company's pension plan has solicited opinions of a sample of the company's employees about a proposed revision of the plan. A breakdown of the responses are here. So is there enough evidence to infer that the responses differ amongst the 3 groups of employees? Okay, so we have responses yes and no, blue collar, white collar, and managers. And the null hypothesis that it's independent of group, or that there's no difference amongst the groups. And the alternative is that it's dependent amongst groups. So let me show you how to do that on the calculator. Okay, so there's our data, and here's our calculator. So again, we have to go to matrix, right? So here's matrix on this calculator, and we'll edit this one. Okay, enter. And let's see, now we want to make it a, well, how many, it goes by rows and columns. How many rows and columns? So there's 2 rows and 3 columns, so 2 by 3, enter. Okay, now let's enter the data, and we have 67, okay, 32, and 11, and 63, 18, and 9. Okay, so there's our data. Check, make sure it's in there correct. does appears to be. Okay, so then we go to stats, tests, just like before. We go up to the chi-squared test. We put in matrix A, so we're all fine. We go to calculate and enter. And here's our chi-squared value, 2.27, so 2.27, and our p-value is 0.32, so 0.32. If it was in fact the null hypothesis was true, that it was independent of groups or no difference amongst groups, it's fairly likely to get this sample result. Sample results vary, so it's quite likely to get this 32% chance. So it's not less than alpha, so there's not enough evidence to infer that there's a difference amongst the groups. And so since the p-value is greater than alpha, do not reject HO. There is not sufficient statistical evidence to infer that the responses amongst the three groups of employees differ. All right, hope that's helpful.